we're actually saying, okay, you might have this basic system here, it covers all your data. Yeah, that's a digital twin. But actually we've moved away from that, and we're saying, whatever it is, the goals of it are that you need to start to do this. And these examples you're giving, you could do those before, but what you're saying was it was actually quite difficult to do. You were having to invest a lot of time to go find that information. And then because you had specific skills to be able to code VBA and connect them to systems, you could automate some of that. But if we had a platform where that data was much more easily accessible, then the time taken to do that analysis would be much, much quicker.
Not only would the time taken be much quicker, but you could actually replicate it across the board.
Yes, that's right. Yeah.
If I've got 50 sites around the world, I can now say, you know what, my lesson is to do this, or my lesson is this. The action, instead of make sure everyone knows about this lesson, which is a typical action, like train people, which lasts about a week, if that long, is actually you're codifying it by saying, you know, making the action go and create this verification across all of our systems that are applicable.
Yeah.
Right. Yeah.
Well, so then if you could write the code in terms of the abstract knowledge of how a well works, so that it doesn't need to speak to the specific tag in the Honeywell or the SetSim or whatever control system, it's like check wing valve or flow meter, oil flow. It's talking in concepts related to this piece of equipment. Then your algorithm could be transferable.
Yes.
Because now it doesn't have to be rebuilt for every single asset. If all the mapping's been done, like you were describing earlier, the relationships are there, then you could write something at a more semantic level of how to do something. And I don't care where you get the data from, but you need the methanol injection flow rate, and you need the wing and master valve and the routing valve on the manifolds, those kind of things.
Yeah, so I think, you know, exactly. So your action's coming out of a lesson out of that. It's the algorithm.
Yeah, the algorithm, and you write it once.
Now it's up to those folks to either, depending on how you have your data set up. I mean, if it's very structured, it could be as simple as do it everywhere, which I think is probably too much perfect, right?
Yes, that's
because you're going to spend forever
21.
doing your data. Yeah, you're going to be spending forever working on getting your data right before you get any value. You can get value pretty quick, right?
Yeah.
Here's the algorithm, and for each site, you need to put in the appropriate tags. For each well, I need to know all the tags for, you know, these different tags for that well. And then once you have that, the algorithm just runs, right? You know, I do think, you know, another view I have of the digital twin is kind of a layered approach, which I think has changed as well. And, you know, if I think about that data, having the data available as a layer of, okay, here's all the data, which is much more accessible now. I think that second layer, which I think many companies are getting into, is okay, what does that data mean, right? And I think I will say that those tools exist today that you can sit on top of that data, in which you can write what I would say just are simple rules. I think machine learning is great, but I think simple rules are good enough, at least to get most of the value, right? Simple rules like, you know, if this does this, then it's an issue, right? This pressure gauge needs to be within here and here. That pressure gauge, and this flow meter are related through this equation, right? Those type of things, right? And so now you can actually tell the system through this layer how the system should be operating, right? This temperature should be between here and here. If the rate on this compressor goes up, then the temperature should go up as well, right? And it should go up approximately on this curve, right? Because we have these types of curves. And it's not using sophisticated simulators. I mean, you can use pretty basic engineering to determine those things. Once you have that, throw all the machine learning in to get the rest of it, right? Because physics you can't solve any of the equations if you keep all of the partial differentials in there, right? You have to start saying, that's negligible. Now I can solve it.
Yeah, you got it. Yeah.
You know, but that next layer is, you know, so now I've got, and this, that layer 2, I would say, is where I would say a lot of folks are going, which is, you know, that control system, that control loop. You know, I can replicate what it should be doing, and therefore, as an engineer, go in and look at it and say, it's actually doing something that it shouldn't be doing. It needs to be retuned. Okay, so that's the value of layer 2, is you've given your engineers, basically, you've given them that data and they've been able to put their rules and logic onto it. That layer 3, or that next step, and this is kind of the process I told you earlier, just in my own experience, is really about, okay, how can I get this? There's still way too much to look at, right? I mean, even a simple upstream production system is not as simple as, certainly not as simple as I thought it'd be as a chemical engineer, right? I trained on like refineries and chemical type of plants. And I was always told, it's just, you know, it's a big dumb system. It's not big and dumb, I can tell you that. You know, so, and there's way too much to look at, right? I had 10,000 tags in my system, or in my spreadsheet, that would get run. And ultimately where I got to is, oh crap, there's too much to look at. And which one should I look at first? And so instead of let me look at it, and, you know, I initially went down the visual path of, you know, I'll just have it tell me red, yellow, or green, and I'll focus on the reds. And you know, it went to more of a, let me use this to tell me what to look at, right? Not just by color, but actually notify me when there's the issues. So in other words, if I don't hear about it, it's fine, right? And it narrowed my scope down quite a bit by doing that. I knew within, you know, by the time I sat down and had my cup of coffee, or was drinking my cup of coffee in the morning, I knew what my day was going to look like. And, you know, and then ultimately with level 4, and this is kind of another layer on top of it, it's being able to now, you know, what I noticed was after a few months, you know, I'm continually doing this every time this does this. I started codifying that in, going, well, wait a minute, you know, why am I having to come up with the same recommendation each time? Let me just codify. If all these things happen, then here's what needs to happen. You know, subsea operator, please go check the, you know, the bypass valve on this chemical, or whatever that recommendation is, or that action is. And so you could, I kind of getting back to kind of that view, is I really see it more in a layered system that, and I don't see it ever ending, to be honest, because, you know, each layer is going to need new information, right? I don't need to determine whether this transmitter is out of its normal operating. I don't need a cause and effect for that. I do need a cause and effect if I want to start developing recommendations when these things are happening. What are the likely causes, and what's my confidence level on what it could be? If I want to prioritize actions, right? Because you know, BP is no different than anyone else. We all have too much to do, right? There are always overdue actions. And every time you go into these action databases and look at what's overdue, and actually put a team on it, which I've done several times, what you find is many of them just didn't need to be done. And that was the recommendation from the team. And you investigate that a little further. And what you find is, oh, that was created 3 years ago. And they just put by the end of, you know, 2020, you know, this needs to be done, right? With no, they were just pushing it out, waiting for the next group. And so, you know, by bringing in and more data, you can actually help prioritize these things with a digital twin. You know, so what's that prioritization? Every company's going to have their own. Certainly in the upstream oil and gas business, a major portion of that prioritization is going to be your HAZOP LOPA, right? Does this impact the risk on my facility? If it does, by how much? This device, you know, this shutdown valve, you know, should be closing in 45 seconds. all indications are in 2 weeks, it's going to be closing beyond that based on, you know, the data. So, you know, that shutdown valve has this risk reduction factor with this risk. That would hold more priority than, we'll just say, a pressure transmitter that has redundant safety pressure transmitter, right?
Yeah. Or
so, but you have to have, yeah, I mean, you have to have, the capability to add those layers to it. And I think that's what's changed as well, is that capability. You know, you can do it in Excel and VBA, which tells me I know we can do it. It's just a matter of how do we set that architecture up to, you know, kind of get that entire workflow through, as opposed to focus on one thing and then focus on the other and then focus on the other. It's never ending.
I think that's exactly right, and you can see examples of that all over the place where things have moved up in complexity, and what we end up with, I guess, is systems of systems. But the systems at the bottom are so well known and so solid that we don't think of them as a system anymore. They just become a thing. But I mean, cars are classics for this. If you actually lift the bonnet, what you find is loads of modules that are there to do a thing, but they're just a complete unit, and you plug it in. It's maybe just a temperature or some feed into the main car's brain, but it actually is a system within itself. So we're always moving up, and we just bank, I guess, our experience before that.